Nobody told me. How do I admit all? Admit all. So that it will be admitting automatically without
Google Meet that use Zoom.
Zoom.
Zoom settings.
Okay, good evening. Once again. Hello.
Good evening, sir.
Good evening, sir. We are here.
Okay, so I'm continuing. So even if we are not able to be interactive, you can still pick the video and follow. So let's see. How do we tackle this type of question? Assuming we are to define EDA, that is exploratory data analysis. After picking your data set, whether it is structured or unstructured, you want to feed it to a machine learning model so that at the end of the day, the algorithms within the machine learning model will be able to get us an insight for our visualization. So our first stage is to after getting the data set is to do what is called exploratory data analysis. It's just like if you are asked to build a bridge. If you get to the site, you have to first of all look at the soil content there, the heights or the depth of the river. And also you have to check the soil type, whether it is clay or it is sandy or whatever. And you have to also check the size of the river or a lot of landscape particulars about the area. It's just like a survey before you'll be able to build the bridge. So in the same way, when I take my data set and I want to solve any data science project or problem, I should be able to perform some analysis to know how the data itself is. So we are trying to discover the main characteristics inside the data set. So we are trying to investigate. On the other hand, we are trying to investigate. So exploratory data analysis, or EDA, I think most of the times I have to still be accepting people like that. Okay. So we should always be able to try and do exploratory data analysis to see the inside or to investigate how the data is before we can use it. So you are not solving the case yet. This is not where we are solving the problem. No. At this point, we are just observing and looking for clues and understanding the layout of the data. So exploratory data analysis comes by trying to have a clue about how the data is. It involves summarizing the data with statistics like mean and median. All these things, I did them in class. So we try to look at the mean. We try to look at a lot of things that goes with the statistical approaches. Then we try to visualize. So you see the university competition data set, I try to plot some charts and graphs for you to be able to understand how the data was made of. So we still have what is called the pattern. You should be able to understand the pattern and issues. Sometimes there will be problems inside the data set, like outliers, like null values, and a lot of things that will worry the model whenever you proceed to build with the model, to build with that kind of data set. So our next point is to look at some practical demonstrations of this kind of exploratory data analysis. So first of all, I'll go to my Python data or my Python interface. Then I'll try and import pandas. Pandas is what I'll be using for this quick review of exploratory data analysis, just to know how my data set is. So one example of data set that I'll be using here is I'm still having problem with this. Okay, let me just admit. Yeah. So one example that I'll be using today is who is that? So as I said, one of the things that we'll be doing is to deal with this kind of pandas. So we'll use pandas as a library to try and do the exploratory data analysis. So let me first of all use my Google Colab. I've already mentioned Google Colab. So I'll just take you there, then we start our programming. So let's see. Let me share that kind of page for you. My programming interface. Then we start our programming. So first of all, I have to import pandas. Import pandas as PD, as we did the other day. PD, then maybe, do I need anything again for now? No, now I don't need anything. Then what I'll do is that I'll go to this place and just upload my data set from the desktop. So I have the diabetes data set. I think you are aware of that kind of data set. So let me just import it to my session. Then we try to use code to call it, because that is it over here, diabetes, but I have to call it into my session. So I have maybe data equal to pd.read underscore CSV, because it's in the form of CSV. Then I open the rest and put I put the diabetics.csv there. So when I run this, it will run. So what do I want to know about this data? Right now, I don't know anything, so I have to use pandas or I have to use these Python codes to be able to see, because right now I've read it into a variable called data. So I can now use it to reference any kind of thing that I need from it. So you remember we said, let's see how the whole data set is arranged. So I'll first of all look at about 5. Always I have to be going there to be admitting students. So that is why I always pause. So forgive me. Now, so what I do is that we will say data.head. If I say data.head, you know that we are just looking at the first 5 rows. So you see, when you look at the first 5 rows, it will start from 0, 1 to up to 4. Because in computing, we normally start counting from 0. So these are the columns. We have the pregnancies, glucose, blood pressure, skin thickness in that order. Then this one becomes our output, or the labels that tells whether the person is having diabetics or not. So this is the first 5 rows. But if I wanted any number of rows, this function should have been given a parameter. So if I say data.head, and I leave it like that, that is where it gives me 5 rows. But if I put something like 3, it will rather work with the parameter that I've passed inside the function. So we know that if we want the last 5 informations to, we will say, or the last 5 rows of the big data set, we say data.tail. Remember that. Data.tail, if I put 3 or any number, I'll be able to have that number at the end of the data set. So you see, if you are starting from 0, we are getting the last value to be what? 7, 6, 7. Then we have 1, 2, 3, 4, 5, 6, because I passed 6 inside the function. Yeah, this is just a simple thing that we can look at. Then we can do data.info. Data.info. Remember, we want to know how many entries are in each column. Each column that we pick, how many entries are there? And we want to also know the data types. Some of them are int, some of them are float, because some of them are text data and some of them are numbers. So in that order. Then we can also look at what data.describe. Data.describe will give us all the statistical meanings or all the statistical values. So we can have the count, the number that is in each column, the mean value or the average, the standard deviation, the minimum value in a particular column, 25th percentile, 50th percentile, 75th percentile, and what? Maybe the maximum value. So that is all about our recap on this kind of exploratory data analysis. As I said, if you pick the data, you are supposed to perform this exploratory data analysis so that you'll be able to understand or know how your data is before you can apply or before you can start applying any kind of machine learning algorithm or data science algorithm on it. So let's go back to our slide, then we continue. Let's continue. Now, so let's look at our next question. Our next prior question. Now, can we explain the rules, the role that is played by this exploratory data analysis? As I've already demonstrated, I say that within the exploratory data analysis, it's a critical step in in data science, because if you don't understand the data, even applying it will be you can even apply it wrongly. So you can't just jump straight into modeling without doing any kind of exploratory data analysis. So if you do that, it's just like you are building a bridge or a house without looking at the foundation or doing the basic inspections that I've already mentioned. So why do we do exploratory data analysis? Number one, we do it to understand the data. We do that so that we can perform data cleaning and data pre-processing or data preparation. We do that so that we can do what is called feature selection. You see, If you want to predict how a student will perform at the end of the semester, there are some columns that you need. If I create a database table or relational database values, then I have things like student name, student ID, student parent, student whatever, with a lot of tables and linked with what? These our keys and whatever. At the end of the day, there are some things that I need to be able to solve a particular problem for a particular student at a time. If I want to look for attachment for a student, I think I have to go into his academic tables that are recording his courses that he did, the grades that he had, and the marks that he had, so that I can recommend the kind of attachment that the student will be going for. If the student has been doing good in computer networking, then I send him to where they are doing computer networking. If the student is good at machine learning, I send him to where we are having machine learning. So, as we see, we have a lot of tables with different kind of columns. If I go and pick a table that is telling me the student parent name, you all know that parent name cannot predict what kind of attachment the student should do or the company that the person should do his attachment. More onto it, you can see that the student index number doesn't count when it comes to sending him to go and do attachment. Your name doesn't count. Your name doesn't tell who you are. Your index number doesn't tell who you are. Where you come from, I think where you come from will tell, because during the vacation, you are supposed to stay home and be doing the attachment. So these are some of the things I want to show you about this kind of feature selection. So whatever that you want to predict, there are some columns that will help you to do that. And those columns are what we call the features. So whenever we have features in what? Any data science table, we say that they are what? The columns are always called the what? The features. As simple as that. The model selection. Doing the exploratory data analysis will let you understand the data, because this data that we've already done, all of you know that I'm not dealing with flower type classification. I'm not dealing with something like price increment of a particular drug in the market. I'm actually dealing with how to classify women according to whether they have diabetics or they are not having diabetes. So that is it about the guidance to how to do the modeling. You now know what type of model to apply. Then it gives us what? Insight generation. In a nutshell, it will give us an insight about the data. Sometimes when you do very good exploratory data analysis, you might not even need to apply any algorithm again. You just get the insight, and you can solve about 80% of the problem that you are encountering. So that is it. Then we have, let's see some kind of IDs. This one you dealt with it with Mr. Metal. So that's a practical aspect. There are some IDs that we use for data science. You have Jupyter Notebook and Jupyter Lab. We have RStudio. Actually, RStudio, I've not used it before, but it looks very much like Python. So I wish some of you, those who are having good machines, after installing the Anaconda, try and install the RStudio too, and let's see. Then you try your hands on it. Then we have Visual Studio Code, that's VS Code. This is a particular powerful IDE that Microsoft have just brought to come and help students to do a lot of things with just some few extensions that will be included. If you include some few extensions, you can be able to use it to do a lot of things. Gone are the days if you want to code in something like Visual Studio, what do you call it? C#, VB.NET and whatever. You have to install a very big IDE called Visual Studio, and it takes a lot of memory when it is running. So these days, this one that has come from Microsoft has become very handy. So it is, and it can be used for a lot of things if you put in the right extension. Are some people still waiting over there? Or what? I hope you're on the same page. Hello?
Yes,
Yes,
sir.
sir.
Good. Now let's go to the next one. Like what I've been using a lot in my class is the Google Colab. Please try and be practicing whatever that I teach you, especially the practical sessions. This one is just free. You don't pay anything, provided you have data. It's just like you're in Ghana. If you're in Ghana, what you need is all what? Data. Yeah, then we have another one called PyCharm. It's also fully done for Python syntax. So it does a lot of things. And especially since we are doing data science and the language that we speak there is Python, the PyCharm will also help us mostly. Then you have Spider. It's also one of the packages inside the Anaconda. But I don't know whether we can get Spider online. But what I know is that for Jupyter, that is what we have online, and it is called the what? The Google Colab. Fine. So that is it. Then can we look at some format after you people were able to deal with the web scraping with Mr. Metal? So let me even hit on it again. If I have a Twitter page and I want to know, or if I have WhatsApp page, let me use Twitter for instance, because Twitter always give APIs for us to be able to scrap data from their page. If you want to know how people are commenting about this cocoa price increment, cocoa price decrement, and whatever, you can just go to the Skype or what? Twitter and be able to scrap the data and be able to sit down and analyze how people are talking about that kind of prices. So what we do is that it's two ways. Either you go there or either you use their API. Skype may give you their API for you to be able to to just copy. An API, you know the meaning, application programmable interface. It's just a particular kinds of rules and interfaces that will help you to be able to integrate your software with a particular package somewhere. So we say that after getting this data, sometimes you can do web scraping. Please, have you been taught The Beautiful Soup by Mr. Metal? Practically. Did you deal with Beautiful Soup?
No, sir.
Okay, then I'll let him, because if he doesn't show you, maybe my assignment, you might not be able to handle it. I've given you an assignment. So if he has not taught you Beautiful Soup, you might not be able to scrap the page that I told you to scrap. So if you're able to get the data from that page, now you have to represent it in one of the file format. And one of the best way of representing it or putting your extracted file is in the form of what? CSV. And the full meaning of CSV is comma separated values. So why do we use CSV? It is having some three advantages: simplicity, universality, and compatibility with data science tools. Number one, it is simple because it is in the form of plain text, formatted with rows and columns. And at the end of the day, they are separated by commas. And it is also human readable. When you are reading data from it, it looks like you are dealing with Excel. Let me say it's a senior brother of Excel. So it makes things easier for you. Then it is universal because it can be opened by almost every data related tool. You can use Excel to open it. You can use Pandas to open it. Anything related to database can be used to open it. So this makes it easy for it to be shared and to be able to work with other researchers from somewhere. Then we say that it is compatible with some data science tools like Pandas. We have already dealt with Pandas. So whenever you are dealing with your data frames, they can easily be converted into CSV files. So I think with the explorative data analysis that I just demonstrated practically, you saw me using this function to even collect the data. Then I save it in the form of CSV. So that is it for now. This is an assignment that I'm giving to you. I actually want to leave the office. The place is becoming scary because where I am, people are not here. We are writing midterm for this week, so all the students are gone. So I have to leave this place. Maybe when I get home, I may try and add another video to you, but try and do this assignment for me. You write a Python script to save the movies to you. See, I gave you an assignment to write a Python script to scrap data from a particular a particular site. So at the end of the day, when you get the data, how do you save it? You save it in a .csv file format, and that is your assignment for now. So I'll collect the other one. then this one too, you do it for me to. I think this one I'll let you demonstrate it online for me to see, because I wouldn't be tolerating this copy work this time around. So that is it. Any question? So when I get home, I think I'm going to continue with the practical demonstration of this location function within data frames using what? Pandas functions. So that is it for now. Please, any question? Any question? But try and be solving all these things that I'm going through with you. It's very, very important. Any question?
No, sir.
I always want to put my recordings on WhatsApp, so we will close here, then I'll just upload it for you. If you have any problems, then you ask when we meet physically. Thank you.
Thank you, sir.
Okay, Makati, continue for us.